In this video, I want to do a little quick review of some very basic physics ideas, and this will come in particularly handy for those who haven't studied physics or for whom it's been a long time. And in particular, our textbook, being kind of old, sometimes uses our English measurement system rather than just the metric system. Now, if you study physics these days, you're probably just going to mostly work in the metric system. But because of some problems in this book are expressed in English units, arcane things like slugs, and then we need to look at both types of measurements here. So let's begin. The unit, the standard unit of length in the English system. Let's write two charts here. Okay, so length is measured in what? Well, we'll probably mostly measure it in terms of feet. And in the metric system, we'll mostly measure it in terms of meters. So meters is abbreviated with a little m. And we don't want to confuse that with mass. Now, the units of mass in the metric system normally will work with kilograms. And not kilograms, but kilograms. And that is kg. Now, a kilogram on the surface of the Earth weighs about 2.2 pounds. But the kilogram itself is not a measurement of weight, it's a measurement of mass. Mass is the amount of stuff that's in an object. And I'm not sure how else to explain that. But mass and weight are really two different things. Now, it's kind of funny because in Europe they use the metric system. They weigh themselves in kilograms. And that's okay if you never leave the surface of the Earth. But the real measurement of weight is, I'll call this force. The real measurement of weight or force in the metric system is called the Newton. And that's capital N for Isaac Newton. So now in the English system, the measurement of force is usually the pound. And of course, pound is lb, foot is ft. What's the unit of mass in the English system? Well, it's a word we don't hear much in this context, and it's called the slug. And I'm not sure if there's an abbreviation for slug, so I'll just write slug. And so there we go. Now, the gravitational pull at the surface of Earth, this is the gravitational acceleration at the surface of Earth. Is abbreviated by g, little g. And in the English system, well, you've got this down, so let's write that out. G is going to be 32 feet per second squared. Now, it's a measurement of gravitational acceleration. Gravitational acceleration in the English system is usually measured in terms of how fast the velocity is increasing every second. So velocity, or speed, and I'll talk about the difference here in a minute, but the units of velocity are in terms of feet per second, and when you talk about acceleration, those units are feet per second, which ends up being feet per second squared. So it turns out that the acceleration due to gravity at the Earth's surface is 32 feet per second squared. Now on this side, the metric system, g is about 9.8 meters per second squared. So it's always length per time squared. Length per time squared. And so if you worried, if something weighed 10 kilograms, well, if something had a mass of 10 kilograms, if you multiply it by 9.8, that means it has a a weight of 98 newtons. So 98 newtons would weigh approximately what 10 kilograms would weigh at the surface, which is around 22 pounds. So anyway, you can fiddle with those numbers there. But the velocity, of course, would be meters per second, and acceleration is meters per second squared. So there's some of the units we'll play with. Sometimes we'll need to multiply mass times gravity in order to get weight. And matter of fact, let's go ahead and write that out. Need to make some room here. So Newton's relationship between force and acceleration and mass is force is equal to mass times acceleration. And so weight is a measurement of force, and it's mass times acceleration, and be mass times g, mg. So that's how we could measure weight, mass times gravity. All right, so those are some of the real basic elements that we'll be using some of here coming up in these videos. And I may have to do some more physics along the way as we go. So I'm going to assume in this course that not everybody has been doing physics and is really has these at their fingertips. I guess one thing I neglected to mention, I mentioned that velocity and speed are a little bit different. Speed is strictly a number indicating how fast you're going. Velocity is not just speed, it's also direction. And so velocity technically involves direction and speed, how fast you're going and along which path. So technically velocity is in 2 dimensions or 3 dimensions is normally measured with a vector function, vector valued function. In 1 dimension, velocity and speed basically are the same. And so now we may indicate a positive velocity going up and a negative velocity going down, for example. And so that's how we build in the direction. In 1 dimension, velocity can be negative or positive depending on up or down, for example. So, okay, well, there's a little bit of a little quick review here of some real basic items from physics, which I'll pull in as we need them.